everyone. In our discussion of microscopes, today we're discussing units of measurements, which happens to be an extremely important topic, which a lot of students end up struggling with because it has numbers and they somehow end up assuming that it has something to do with math, and they don't usually get the conversion and units of measurement correct in order to answer questions on the exam. And for this lesson, we are going to focus on how to not fall into the same trap that they do and make it super easy for ourselves to first of all recognize the different units of measurement or different units of length, to be precise, that exist when we're solving questions in biology, because the only thing that we are going to solve for is going to be the length of the cell. You see, every single cell has a different length or a different size, and not just the cells, but the structures within the cell also have a different size. And when we are viewing these structures under a light microscope or an electron microscope, we would like to know what their actual size is, and we would like to determine which one is the smallest organelle or which one is the largest organelle, and similarly which cell is smallest and which cell is largest. The size of a cell and organelle has multiple consequences in the functioning of the cell and of the living organism, which is why we must be aware of the size that the cell or organelle has. But in order to determine the size of the cell or organelle, we must be able to measure that length of that cell or organelle that we're trying to get to know the length of or size of. When we're doing that, we must keep in mind the SI unit for length is meter. Therefore, when we are measuring or calculating the length of these structures, we must also be using meters to calculate it. The only problem is that meter is a relatively large SI unit for length, and the cell structures that are found within our bodies are so tiny that they cannot be even visible. They are not even visible to the naked eye. And so the length of these cell structures will actually be a millionth or a billionth of a meter. And in that case, it's going to be extremely difficult to constantly keep saying that. Which is why, as a solution, we ended up creating more units in multiples of 10 from meter, depending on how big or small a structure is. And in order to solve for the conversion of one SI unit into the next one, it is important that you remember the term and you remember the power of 10 that that term represents. So, for example, a kilometer represents that 1,000 meters is required to form a single kilometer. So that can be represented by a power of 3 on 10, because 10 to the power 3 is equal to 1,000, and that means that 1 kilometers is equal to 1,000 meters. So kilo means 10 to the power 3. Similarly, milli, the prefix milli before the term meter, represents a power of 10 to the power minus 3. That means it is 1,000th of a meter. So you need 1,000 millimeters to convert a millimeter into a meter. Another term that is missing from this table is centimeter. Centi represents 10 to the power minus 2, which means you will need 100 centimeters to create 1 meter. And so it is important for you guys to remember that milli represents 10 to the power minus 3, micro represents 10 to the power minus 6, and nano represents 10 to the power minus 9. And this is always going to be with respect to a meter. So in centimeter, 10 to the power minus 2 compared to a single meter. So 1 centimeter or 1 centimeter is actually going to be 10 to the power minus 2 of a meter. Similarly, 1 millimeter is going to be 10 to the power minus 3 of a meter. Micrometer, 10 to the power minus 6 of a meter, and nanometer, 10 to the power minus 9 of a meter. The most commonly dealt with unit when you're doing or measuring lengths in biology or measuring lengths of cell, to be precise, you will be dealing with a lot of micrometer in that question. And most of the time, if the actual length is already given to you in a question, it's always going to be in micrometer. And also remember that most of the time when you're measuring things from your ruler directly, your ruler mostly has centimeters on it and millimeters on it. So you must be able to convert those centimeters and millimeters to micrometers. And that is what the most important part of this lesson is: converting one unit of length into another unit of length. To start off, let's convert 1000 centimeter into millimeters. While we're solving for this, I would like to break the entire process down into a series of steps. And for those of you who do not like math, I don't want you guys to think that what we're doing is math. Consider this as a lesson that contains a series of hacks that will help you converting one unit of length into another, and will eventually help you reach the right answer. The first step in this entire process is to obtain a standard ratio between the larger unit and the smaller unit, which means that when one of the unit is equal to a 1, what is the value of the other unit going to be? To do this, I would like you to memorize the table that I had just shown you earlier, so that you remember which unit is the bigger unit out of them and which one is the smaller unit out of them. For example, millimeter is equal to 10 to the power minus 3, whereas centimeter is equal to 10 to the power minus 2. That means that centimeter is the bigger unit because it has a power of minus 2. The power is a negative, which is why this is a bigger number compared to this, which is equal to a power of minus 3. So millimeter is equal to a power of minus 3. If you don't see how that is, 10 to the power minus 2 equals 1 over 100, whereas 10 to the power minus 3 equals 1 over 1000. And in each case, that gives you a value of 0.01 in the case of 10 to the power minus 2, and it gives you a value of 0.001 in the case of 10 to the power minus 3. So amongst these numbers, 0.01 is a bigger number compared to 0.001. So the first step is knowing that table that I had shown you for the SI unit of length, and memorizing which one of them is bigger and which one of them is smaller. Once you've done that, the second step is to recognize in a given question which unit is the smaller unit and which unit is the larger unit. In our case, we've identified that millimeter is the smaller unit and centimeter is the larger unit. In the second step, I want you guys to take out a ratio between centimeter and millimeter. And now when you're doing that, I want you guys to keep the larger SI unit on top, whereas the smaller SI unit will behave as the denominator in that equation. So in this case, it is centimeter that is going to be the numerator and millimeter that's going to be the denominator. Now, what does centimeter represents again? It represents 10 to the power minus 2. And what does millimeter represent? It represents 10 to the power minus 3. And at this point, if you don't remember indices, let me just quickly make it simple and easy. If the bases are the same, in which case, in our case, that is true because both of them have 10 as their base, the powers can be subtracted in case both of these are dividing with each other. Right now, what we're doing when we're taking out a ratio is dividing centimeter by millimeter, which means we're dividing 10 to the power 10 to the power minus 2 with 10 to the power minus 3. And in doing so, I want you guys to subtract the two powers. So 10 to the power minus 2, subtract that from 10 to the power minus 3. In this case, just write the minus 3 here because the powers become the common. That's the common part, so that stays as the common bit. Now, the minus minus here behaves as a plus, so this basically turns into 10 to the power minus 2 plus a 3, and then that leaves you with 10 to the power 1, and 10 to the power 1 is equal to a 10 itself. Now the number that you have just taken out represents that this is how many smaller SI unit you need in order to create one of the larger SI unit. So now the third step is writing that in a sentence structure. In our case, that's going to be you need 10 millimeters to create 1 centimeter. That essentially means that our ratio is 10 millimeter is to 1 centimeter. Now, once you have this, you can simply use the ratio method to calculate the unknown. You already have 1,000 centimeter, and you need to find out how many millimeters do you need to have 1,000 centimeters. And now we can simply cross multiply to get our answer, because if 1 centimeter is equal to 10 millimeters, 1,000 centimeter is equal to x millimeters. That is what this tiny little cross multiplication is telling you. When you cross multiply these, you actually end up with x that is equal to a 10 being multiplied by 1,000. And that leaves you with x is equal to a 10,000. So 1,000 centimeters into millimeters is equal to 10,000 millimeters. That is what you were calculating. You were converting 1,000 centimeters into millimeters, and this is your answer. 1,000 centimeters is equal to 10,000 millimeters. And that is how you convert one SI unit of length into a second SI unit of length.
Quick pause. If you're finding value in this explanation, there's so much more to discover at Alt Academy, where we break down every A-level concept with the same clarity. Now back to the video lesson.
Let's do another conversion from this method now. Let's convert 1,000 millimeters into micrometers this time. To do so, let's identify which one of these is the bigger SI unit. Millimeter equals to a power of 10 to the power minus 3, and micrometer is 10 to the power minus 6. In this given scenario, millimeter is the bigger SI unit and micrometer is the smaller SI unit, which is why millimeter is going to be our numerator and our denominator is going to be a micrometer, which means that it is 10 to the power minus 3 being divided by 10 to the power minus 6. And now that our bases are the same, we can again apply the rule of indices and get minus 3 and then subtract the minus 6 from it, which is going to leave us with 10 to the power minus 3 plus a 6. And that leaves you with 10 to the power 3, which is the same as a 1,000. This means that you need 1,000 micrometers to have 1 millimeter. And now that you've established a ratio between millimeter and micrometer, you can now find out how many micrometers is equal to 1,000 millimeters. And now you need to simply cross multiply the two. So that will leave you with x, and the x is going to be equal to 1,000 multiplying by 1,000. That leaves you with 1,000, and then you add the 3 zeros to it. So that is how many micrometers will form a 1000 millimeter. If you note that this number has 6 zeros and a million has 6 zeros, and a million can be represented by 10 to the power 6. So you can also say that you need a million micrometers in order to have 1000 millimeters. For the next ratio, I need you guys to pause this lesson and try solving it on your own. You need to solve for what or how many nanometers will be there in 1000 micrometer. Once you've done that, hit the play button again and follow along with me to see if you've done the conversion correctly. So now if you solved it already, the first step you should have done is figuring out which of these two SI units is the smaller SI unit. In this case, nanometer is equal to 10 to the power minus 9 and micrometer is 10 to the power minus 6. So micrometer is the bigger SI unit and nanometer is the smaller SI unit. And so micrometer becomes your numerator and nanometer behaves as your denominator. Since our bases are the same, we can simply subtract the powers, and when you subtract minus 6 from a minus 9, you are left with 10 to the power minus 6 plus a 9, and that is equal to 10 to the power 3 again, which means that that is equal to 1000. And that signifies that you need 1000 nanometer in order to get 1 micrometer. Now, once you've established the standard ratio between micrometer and nanometer, we can now figure out the unknown. We know that 1 micrometer is equal to 1000 nanometer. Then we can figure out what 1000 micrometer is going to be in terms of nanometer. Simply cross multiply and we'll get our value. In this case, x is going to be 1000 being multiplied by 1000 again, which is going to leave us with a similar answer to our previous equation or previous conversion, in which case again you need a million nanometers to get 1000 micrometers. Okay, now that you've come so far, let us now convert 100 nanometers to millimeters. Up until now, you were converting a larger SI unit into a smaller SI unit. For example, our last conversion was converting micrometer, which was a larger SI unit, to a nanometer, which was a smaller SI unit. But this time around, you're going to convert nanometer, which is 10 to the power minus 9, to millimeter, which is 10 to the power minus 3. So millimeter this time around is the bigger unit and nanometer is the smaller unit. That was also the first step in doing the conversion, so that will remain the same. So now that you know that your bigger SI unit is millimeter, you write that as your numerator and then you write nanometer as your denominator, which would mean that 10 to the power minus 3 is being divided by 10 to the power minus 9. If you apply the rule of indices to this now, you can go from minus 3 and then subtract minus 9 from it. And when you're doing that, that basically becomes 10 to the power minus 3 plus a 9. That leaves you with 10 to the power 6. And that means you need a million nanometers to make a single millimeter. And so the ratio or the standard ratio between millimeter and nanometer is that 1 millimeter is equal to a million nanometer. But we need to find out how many millimeters is equal to 100 nanometer. So that's what we're looking for. Now we need to simply cross multiply in order to get the value of x. In doing so, you will initially get that looks something like this, and you need to find out what x is, which is why you're going to let your x stay on this side, and you're going to move your 10 to the power minus 6 as the denominator. So I've simply taken the 10 to the power minus 6 and have divided the 100 with that 10 to the power minus 6 so that you can get your x alone or by itself. Now you can also write 100 as 10 to the power 2. So now that your base is, the reason why we're doing that is because this is already 10 to the power 6. If you could convert this 100 into the same base of 10, you can then apply the same indices rule that we were initially applying to find the standard ratio between millimeters and nanometers. So now if you convert this 100 into 10 to the power 2, you'll be left with something that looks like 10 to the power 2 is being divided by 10 to the power 6, which means you can now apply the indices rule, and this is going to be 10 to the power 2 minus a 6. This time there is no negative with the 6 and it's a positive 6. So this time the 6 will get minus, and since 6 is the bigger number, that's the sign that's going to stay. So this will become 10 to the power minus 4, which means that 100 nanometers is equal to 10 to the power minus 4, or 0.0001 millimeter. So do you see how small this 100 nanometer was? That to get 100 nanometer, you only need 0.0001 millimeter. If you have that, or 10 to the power minus 4 millimeters, you'll have 100 nanometers, not just 1 nanometer but 100 nanometers. So that goes on to show how small nanometer is. Finally, for your last conversion, let's move away from tens and hundreds and move to converting 400 nanometers into centimeters. We still do the same steps, which is the first step being figuring out which one of these SI units is larger and which one of them is smaller. So centimeter is 10 to the power minus 2. Sorry, there's a minus there also. Let me fix that. That's supposed to be 10 to the power minus 2, and nanometer is supposed to be 10 to the power minus 9. Amongst these two, centimeter automatically now becomes the larger SI unit, so that becomes the numerator, and nanometer is the smaller SI unit, so that becomes the denominator. This means that 10 to the power minus 2 is being divided by 10 to the power minus 9. Now that comes out to be a 10 to the power minus 2 minus a minus 9, which leaves you with a 10 to the power minus 2 plus a 9, which means that this comes out to be a 10 to the power 7. This means you need 10 to the power 7 nanometers to get a single centimeter. So now we know if the standard ratio is 1 centimeter is equal to 10 to the power 7 nanometers, how many centimeters is it going to be for 400 nanometers? Now you simply cross multiply to get the value of x. This leaves you with the 400 being divided by 10 to the power 7. Now the tricky part here is that you have a 400, so this is not 100 that you can convert into 10 to the power 2, 10 to the power of 2. To do that, can you also write 400 by multiplying 4 into 100, right? Isn't this equal to this? And so can you write 4 into 100 divided by a 10 to the power 7? And since if you can do that, you can also write 4 into 10 to the power 2 divided by a 10 to the power 7. Since now the bases of 10 to the power 2 and 10 to the power 7 are the same, you can now again apply the rule of indices, which leaves you with 4 into 10 to the power 2 minus a 7. That leaves you with 4 into 10 to the power minus 5, which means that 400 nanometer is equal to 4 into 10 to the power minus 5 centimeter. The whole purpose of doing so many conversions was to familiarize you with converting a small SI unit into a larger SI unit and then converting a larger SI unit into a smaller SI unit. I initially tried making you guys convert by staying within tens and hundreds in terms of the numbers, but then now I have also introduced you to a number that is not in tens and hundreds. And so, if questions on the exam show up that ask you to convert one SI unit into another, or for example, when you're doing magnification and resolution in your microscopy, a lot of times you will have to convert centimeters into micrometers, or you'll be converting millimeters into micrometers also. So if you can convert the basic if you can perform this basic conversion, I'm sure and confident that you guys will be able to convert centimeters and millimeters to micrometers while performing questions on magnification also. And hopefully you won't be getting them wrong. So now that you are already comfortable with converting one SI unit into another, let's move on to our next lesson, which is going to be about magnification.
Hey there! If you found this A-level biology lesson helpful, why don't you head over to altacademy.org and sign up for our full A-level biology course. In addition to biology, you could sign up for physics, chemistry, math, or 4 other A-level subjects. Thousands of students have already taken the leap. What are you waiting for? See you there.